Okay, so let's talk 2.3. So we have problems 2 and 3 that I'm trying to answer, but I think I probably need to consider problem 1 at least. Okay, so first things first, I need to, in problem 1, write down some 3 by 3 matrices that produce some elimination steps. Okay, so how do I do that? All right, let's check. So I want to subtract 5 times row 1 from row 2. So I'm going to start with the idea that E21 is the matrix that just leaves everything alone. Right? If I put 1s down the diagonal and 0s everywhere else, this matrix leaves everything alone. You guys all see that? Yes? Maybe?
Yep.
Okay. Does this matrix subtract 5 times row 1 from row 2?
Nope.
No. Okay. So let me think about what I need to change. I have this vague recollection that if I want to do something with row 1 and row 2, it's probably going to have to go either here or here. Does that thought make sense? One of the ways I'm kind of thinking about this, right, is I'm thinking, okay, so if I multiplied this by something, like let's say x and y and z, right? So I'm taking E21 and I'm kind of thinking about multiplying it by x. I'd really like to get, right, if this was completely working, I would get x on the top and then subtracts 5 times row 1 from row 2. So I should have row 2 minus 5 row 1. You guys all kind of with me on the idea of what I want to get? Okay, so now I'm going to just try putting something in one of these. My guess is that it's going to be the number -5. You all with that? Okay, so I'm just going to slap -5 in here and then consider this multiplication. So if I do this multiplication, right, I'm going to pick x, y, z up, I'm going to twist it sideways, and I'm going to drop it on that first row. What am I going to get out of that?
X minus 5y.
Oh, I'm going to get x minus 5y. I wanted this to be x. Shit. It's in the wrong spot. You guys see that? That's how I'd subtract 5 times row 2 from row 1. That's not what I want. So I'm just going to try the other spot. So I'm going to try putting a -5 here and a 0 here. Okay, so now if I pick my x, y, z up, twist it sideways, and drop it on, I'm going to get, well, I think I'm going to get x. And then if I do that again, pick this up, twist it sideways, drop it on, I'm going to get -5x plus y. Oh, rad. That's what I wanted. And then what happens to the last row?
Stays the same.
Stays the same. Okay. So this is the matrix that I wanted. So now I can just kind of dump my scratch work here. So my scratch work was having the idea of a vector x and having this result. Okay, so I'm comfortable that that's the answer to part A. Is all with that? And if I wanted a demonstration of that, I'd write down my little scratch work there. Okay, how about E32? They say I want to subtract 7 times row 2 from row 3. So I'm going to start out guessing that's the identity matrix. And now I'm pretty sure that if I want to subtract things, I probably should just put them down here. You guys see that? If I want to subtract from the rows below, I need to put them kind of underneath the diagonal. At least that's my guess. So I'm supposed to subtract 7 times row 2 from row 3. So my guess is that that's going to go in either, let's see, this spot here or this spot here. Does that thought process follow? You guys see why I'm picking those? Have I talked about addressing matrices at all? The book does, but I don't know if I have. So this thing here is the entry that's in the second row, third column. This one is the one that's in the third row, second column. You guys see that? So addressing is done the same way matrix size is done. It's just row by column. Now, does it make sense that if I want to mess with rows 2 and 3, I should probably be looking at the 3, 2 and 2, 3 entries? Does that sort of follow? I can't tell whether you guys are bored or confused. And this is maybe confusing, so I need to know where you're at.
That makes sense.
Okay. All right. So if I'm going to mess with these two, I'm going to try my -7. I'm going to try that out in the spot down here. And then I'm just going to test to see if it works. All right, so I'm going to take my E32 vector, or my E32 matrix, and I'm going to multiply it by a vector x just to check. So that's going to be 1, 0, 0, 0, 1, 0, 0, -7, 1. And I'm going to take that and multiply by a vector x, y, and z. And I'm hoping to get a vector x, y, and let's see, I want y -7z here. Is that right? No, that's not right. What am I supposed to get?
Z -7y?
Yep. I'm supposed to take row 3 and subtract 7 row 2. So I should get this out of this thing. Okay, so if I pick this thing up, twist it, and drop it on here, I'm going to get x. If I pick this thing up, twist it, drop it on, I'm going to get y. And if I pick this thing up, twist it, and drop it on, I'm going to get -7y plus z. Okay. Seems legit. B. You guys with that?
Yep.
Okay. Now, I don't think I need part C. You guys see that? To do this? So I'm just going to move on to problem 2. You can figure out part C by thinking about, you should have P, X, Y, Z. The first thing it should do is exchange row 1 and 2. So it should take this to row 1 and 2 exchange would be Y, X, Z. And then exchanging rows, blah, blah, blah. Figure this out. It's not super hard. I don't know why I said I wasn't going to do it and then started doing it. I'm going to stop. You guys got that one. It's not hard. All right. In problem 1, applying E21 and then E32 to B gives something. Okay. So what they want me to do for problem 2 is they want me to start out by saying, all right, so I'm going to take my vector B, right? I'm going to hit it with E21. I'm going to get E21 applied to vector B. You guys all with me on the function idea there? This would be like x turns into f of x. You guys all on board with that? ish. Okay. Then I'm supposed to apply, so it's applying E21, that's this, and then E32. So that's going to be E32 here. So I'm going to have E32 that I did to E21 and the vector B. You guys all see that? And then you'll notice that the book doesn't need, they don't put these parentheses in there. The reason they don't put those parentheses in there is that matrix multiplication is associative, just like multiplication of numbers is. Okay, and then I'm supposed to actually compute this, right? You guys with me on that? So one way I could compute this is I could actually write down all my matrices. So I could write down my E32 matrix. That was 1, 0, 0, 0, 1, 0, 0, minus 7, 1. And then I could write down my E21 matrix, which was 1, 0, 0, negative 5, 1, 0, and 0, 0, 1. And then I could write my vector B down. It's 1, 0, 0. And then we could do this multiplication. So the first thing it's going to do is leave this thing alone. So I'm just going to copy that guy. Oops. Oh, come on. So I'm going to get that guy, and then doing this multiplication here, I'm going to get 1, negative 5, 0. You guys all with me on that one? That's kind of a bunch of pickups and drops on. Or you could think about it as, look, there's only a 1 in that top coordinate, so I'm just going to get 1 times the first column here. That's what this guy is. Everybody with me on that? Okay, now if I do this thing, I'm going to get 1 times that first column. So I'm going to get the vector 1, 0, 0, minus 5 times that second column, plus 0 times the third column. And so out of that, I'm going to get, I'm going to get 1 and negative 5 and negative, oops, that was supposed to be negative, positive 35. Or you can do this with the row multiplication picture, right? You can pick this thing up, you can twist it sideways, and you can drop it on. You can take this thing, pick it up, twist it sideways, slam it on. You guys see that? Either way, you're going to get to here. Any questions on that? Is this Zoom meeting set up so you guys can react to things? Do you have little emojis that you can use? Cool. All right. Give me one of those every once in a while, huh? That way I know I'm not just shouting into the void here. All right. So in the end, I got this thing. Now, another way I could have got that is I could have thought about what it's doing to the rows. Right? So if I thought about what's happening to the rows here, E21, right, subtracts 5 times the first row from the second. So in this vector, the first row is 1. And so I'm going to subtract 5 times the first row from the second. That's going to give me 1, negative 5, 0. And then we could think about that again. You guys with me on that? All right, now they're asking about doing this in the other order, right? So if I do this in the other order, that's going to be essentially, I just need to pick all this stuff up. And then I'm going to have some cleanup to do. So I'm going to drop that. And then I need to apply these in the opposite order. I probably should have just rewrote this crap. It's easier. Okay, so same problem, different order. I have E32 first. That's going to give me E32B. And then we're going to do E21 to that. You guys all with me on the flip-flop here? So I'm just doing the same thing in the opposite order. Seems like that shouldn't do anything different, right? So does it seem like
Should be equal because it's associative.
Yeah, I mean, it probably
Yeah.
feels like it should be because this is how numbers work, right? Like numbers have this property that you can interchange the order and it doesn't matter. This is just multiplication, right? Yeah, it's not multiplication. So what is it that makes this different than multiplication? Remember when I introduced this at the very beginning, I said, remember, a matrix is a function.
The function E32 of E21 is different than E21 of E32.
Yeah, remember this is function composition, and exactly like Cody says, when you do one function and then the other, that's a different outcome than when you do them in the opposite order. This is a lot like if you think about the two functions in your everyday life of open the garage door and back out of the garage, right? If you open the garage door and then back out of the garage, things are fine. If you back out of the garage and then open the garage door, you have some problems, right? That joke usually lands a lot better. Thank you, Jackie.
Well, I mean, if you back out of the garage, then you kind of do them both at the same time. You open them at the same time.
Yeah, if you back out of the garage, it's a lot harder to open the door afterwards. That is a good point. Sometimes when you apply one function, applying them in the other order doesn't even make sense. All right, so if I actually compute this, right, I should be able to see that those things are different. So if I take my kind of 1, 0, 0 matrix, or my 1, 0, 0 vector, and feed it into my E32 function, I notice that I get this first function, or yeah, my first matrix, I'm just leaving that one alone, right? So I'm just writing that one down again. But now when I apply this vector, or sorry, when I apply this function, that's my E32 function, to the vector 1, 0, 0, I get out just the vector 1, 0, 0 again. You guys see that? Because what that thing does is that thing messes with row 3 and row 2. Well, row 3 and row 2 are 0 here, so who cares? You guys see that? And now if I apply this function, so I'm applying the E21 function to the vector 1, 0, 0, I get the vector 1, negative 5, 1. 1, negative 5, 0. I did that one before, so I'm just reusing a calculation. And then I notice that these are different. Which means, right, so that implies that E32, E21 is not the same as E21, E32. You guys see that? Function composition, the order really matters. It's still associative, right? But the order matters. You guys good with that? I had a professor in Bozeman that wrote a textbook that, like he wrote his own pre-calculus textbook, and so we all had to use it. And it said order matters about every, I don't know, second or third page. It was bolded everywhere. We, as graduate students, we kind of felt like it was a little bit of a joke. But it turns out that if you repeat order matters to yourself a lot, you'll actually see a lot of spots in your life where order does matter a lot. Like you'll drop something on the ground because you got it wet before you picked it up or something, and you'll realize that order matters. This is a way of life. It's not just a philosophy for math. Take this with you. Join my cult. Sign up for my pamphlet. All right, any other questions on... I guess I didn't answer 3. And I think we could say that when E32 comes first, row 3 feels no effect from row 2. All right, and then which 3 matrices? No, I am a strict non-Kool-Aid cult. Sorry. My bad. All right. The 3 matrices to put A into triangular form, that we might want to fiddle with in a separate problem. So let me pause the recording.